We're going to be taking on the energetics of beta oxidation and the summary of fatty acid degradation. In the last video, we took on the beta oxidation pathway, and we were able to break down the acyl CoA, the fatty acyl CoA, into acetyl CoA. So we're going to be using palmitic acid as the example here. We assume that the fatty acid we broke down is palmitic acid. So we are going to find out how many ATP this palmitic acid can actually generate for the cells to use. So you could use, maybe I'm going to use palmitic acid. So to actually test your level of understanding, you can use steric acid. After watching this video, you can use steric acid as an example, because this video I'm using a formula. I generated a formula that will make the work easier for us. So I generated a formula that will make the work easier for us. So I'm going to use this. I'm going to use this palmitic acid. This palmitic acid as an example. So if you look down here, you'll see that we have, I said, each NADH. Remember we generated in the pathway, we generated NADH and FADH, FADH2, and also generated acetyl CoA. But there was nothing like a direct ATP generated. These ones are indirect ATP generated. You understand? But there was no direct ATP generated, unlike the glycolysis. In glycolysis, you see, in the pathway, it generates 2 ATP. Yes, we generate 2 ATP, as in the net ATP generated in the pathway glycolysis, like glycolytic pathway, is 2 ATP. But here, we don't generate ATP in the pathway, in the beta oxidation pathway. We actually generate ATP equivalents. You understand? These are ATP equivalents. They have to, this NADH and FADH have to be taken to the electron transport chain to actually get through oxidative phosphorylation to actually get oxidized to generate ATP. So, and this acetyl CoA has to through Krebs cycle is to generate this NADH and FADH that will be taken to the electron transport chain in the mitochondria to generate what? ATP through what? Oxidative phosphorylation. So meaning that there must be oxygen for beta oxidation to actually generate ATP. Yeah, oxygen was very, because the oxidative phosphorylation function with oxygen. There must be oxygen for it to function. So when there's no oxygen, what do you think? We only generate equivalents of ATP, plenty equivalent of ATP, but there's no way to oxidize them through oxidative phosphorylation. So that means there will be no ATP generated to break down oxidation. So there must be oxygen for oxidative phosphorylation to occur. So now let's go into the main reason why we are here. So now, like I said, this ATP you see here is actually generated from NADH. So NADH generates 2.5 ATP. The old value is actually 3, while FADH to generate 1.5 ATP, while the old value is 2. So now this is actually the new values. So the new values are 2.5 and 1.5. So that's what we're going to be using in this video. So on textbook you see 3 and 2, but the new values are 1.5 and 2.5. So now that's when they are oxidizing the electron transport chain. This is the amount of energy, the amount of ATP they generate. So now let's see how many NADH is generated when we actually fully oxidize this palmitic acid, and how many acetyl CoA we generated when we fully oxidize this palmitic acid. So I have a formula. There's the formula here. says, we'll start with this formula first. It says the number of beta oxidation cycle, as in the number of cycle of beta oxidation, is equal to number of acetyl CoA A minus 1, right? Then this second formula says the number of acetyl CoA A produced is equal to number of fatty acid carbon atom divided by 2, right? Then the third formula says number of cycle of beta oxidation is equal to number of NADH. Then the fourth formula says number of cycle of beta oxidation equals number of FADH. You can see these two formulas are similar. The last two formulas are similar. Very, very similar. So now, which formula do you think we start with first? We start with this. The number of acetic CoA produced equals number of fatty acid carbon atom divided by 2. So let's start with that. So we are starting with palmitic acid, right? Palmitic acid represented with P, and it's equals to how many carbon atom? 16 carbon atom. So now divided by 2, we get what? We get 8. That means we generated 8 acetyl CoA. So let me go back here. All right, 8 AC. The AC stands for acetyl CoA. So now let's go back. So check the formula again. What did the formula say? So we have gotten the number of acetyl CoA now generated. So now said the formula. If you look up here, you see that the formula says number of cycle of beta oxidation equals number of acetyl CoA minus 1. Acetyl CoA produced minus 1. Number of acetyl CoA produced minus 1. So we've gotten the number of acetyl CoA produced. So now for us to get the number of cycle of beta oxidation now, we will now minus the number of acetyl CoA produced. We will minus 1 from the number of acetyl CoA produced. So let's go. So number of acetyl CoA produced was 8. So if we minus 1 from it, we get 7. So the number of cycle is 7. So now we'll go back. Number of cycle, I'll separate it from this ones. Number of cycle. So number of cycle is 7. So now, if you take a look at the formula again, it says number of cycle of beta oxidation equals number of NADH produced. Number of cycle of beta oxidation equals number of FADH produced. So we've gotten the number of NADH and FADH produced. Simple. So that means number of NADH, we're trying to calculate this one, is 7. 7 NADH and 7 FADH 2. So let's go back there and put it there. Then let's start getting the values. So 7 NADH and 7 FADH2. Yes. So now we have to get the total number of ATP we actually generate from this palmitic acid. So for us to get that now, let's assume we've actually taken this acetyl CoA to the Krebs cycle. We've generated NADH, FADH. So now we're going to try to oxidize through oxidative phosphorylation. We're going to oxidize this and generate ATP. So now each ATP gives us 10. Each acetyl CoA gives us 10 ATP. So now, and we have 8 acetyl CoA here. That means 8 times 10. You have 80 ATP. So that meaning that this 8 ATP we generate, this 8 acetyl CoA, this 8 acetyl CoA will generate 80 ATPs. So now this FADH, remember FADH is 1 FADH will give us 1.5 ATP. So now we have 7 now times 7. You will generate what? 10.5 ATP. So 10.5 ATP. So now, if we go to the NADH, remember the NADH is 2.5. So times 7, we'll get what? 17.5 ATP. So we generated 10.5 and 17.5 ATP. So now we're going to add everything together. So remember, the acetyl A generated 80 ATPs. 80 plus 10.5 plus 17.5. So this plus this, you get 28, right? Plus 80, you have 108. So we have 108 ATP. We are not done. Do you remember that I actually explained something when we were about to actually finish the video on beta oxidation pathway? I said during the activation of the fatty acid, that means during the conversion of fatty acid to fatty acyl CoA in the cytoplasm. Remember, we used ATP. We broke down ATP into AMP, right? So now we go down ATP into AMP. So this ATP broken down to AMP is equivalent to you breaking down ADP to ADP into, sorry, 2 ATP, broken down 2 ATP into 2 ADP. It's equivalent to the same thing because we've broken high energy bond twice here. At this place, we've broken high energy bond twice. If you watch the video on that activation, you will see that we broke this ATP. We remove one phosphate, one inorganic phosphate. Then then the pyrophosphate left. We broke it again. Broke the pyrophosphate, and we actually generated 2 molecules of inorganic phosphate. So meaning that we broke 2 high energy bond twice. Like we broke the high energy bond twice, meaning that we broke 2 high energy bond. So now, since we broke 2 high energy bond, that means we are going to pay, since remember I said the 2 ATP is equivalent to 2 ADP. So that means I'm going to pay with what? 2 ATP. We're going to pay with 2 ATP. We're going to pay with 2 ATP. So now we generated 108. 108. So 108 minus 2, you have 106 ATP. So we have 106 ATP. So that means the total energy, the energy generated from breaking down palmitic acid is 106. So any fatty acid you're actually going to calculate for, you must remove this 2 ATP from it, because to actually activate any fatty acid, you just need that ATP exactly the way it was activated. The fatty acid, the fatty acid, you don't know the actual fatty acid that was actually activated. Fatty acid, it could be steric, it could be palmitic. There was no specific name on it. It was just fatty acyl, meaning that it's from the carbon atom is from 4 upward. So you don't know the actual carbon atom that was actually oxidized. But now we're actually being specific here by picking palmitic acid. You understand? So, but for you to test your knowledge, I will advise you to pick steric acid after watching this video and test your understanding. So we generated, remember we generated 106 ATP. So this is more than what we actually generate if we actually break down glucose. So you break down glucose, generate 32 ATP. Generate 32 ATP. But here we generated 106, whooping 106 ATP. Imagine that. Wow, that's plenty. So now um I will show you guys the summary of beta oxidation. So the summary of beta oxidation is Fatima. So this is summary of beta oxidation. So Fa meaning fatty acyl CoA, T transported I into mitochondrial matrix, A acetyl CoA, FADH, and NADH are generated. All these were generated, then high amount of energy generated. So remember, we brought the fatty acyl CoA into the mitochondria, we transferred it to the mitochondria. Then after through beta oxidation, we generated all this. So after beta oxidation, what do we do? We generated high amount of energy, plenty of energy. So and you have to remember what actually stimulate this pathway and what inhibit it. But I'll still I'll make a video on the regulation of beta oxidation pathway. So, but the stimulations, what stimulated the hormones that stimulate this pathway is glucagon, epinephrine, cortisol. Then the hormone that actually inhibits it, the chief hormone is insulin. So insulin inhibits this pathway. Insulin favors synthesis, not degradation. So thank you for watching, and please subscribe and turn on the notification bell. Thank you so much.